In this video, we are going to use a histogram to work out the lower quartile of some pupil data. The Maths GCSE scores of some pupils are shown below. Notice I'm not telling you how many pupils are in the data set. Now, this is actually an incomplete histogram because there are 18 pupils whose scores are in the interval 170 to 200. Use this to complete the histogram. So I'm telling you that the frequency, i.e. the number of people who have scores between 170 and 200 is 18. Now, the formula that we need for histograms is frequency density. So frequency density is equal to frequency divided by class width. Now, I like to put this into a triangle for easy rearranging. So frequency density is frequency divided by class width, and obviously then there's a multiplication between frequency density and class width. That's just our standard way of using formula triangles. Now, between 170 and 200, the class width is going to be 30. Simply going to be 200 take away 170, which is 30. So the class width is 30, the frequency is 18. We're told that, therefore the frequency density is 18 divided by 30, which is 0.6. So I'm going to, ideally with a ruler, but I haven't got one, so just draw my bar between 170 and 200, remembering that frequency density is on the y-axis. And that would be, now the histogram is complete. Now, for part B, this is the real, this is the tricky part of the question. But in a GCSE exam, you get a lot of marks for simply locating the interval in which the lower quartile exists. Now, there's essentially 4 steps, so I'll just summarize them briefly before doing them. We are going to work out the frequencies of each interval, or each bar I could say, and work out the total to work out how many pupils are actually in the sample, or in the population. We are then going to divide that total by 4, which will give us which pupil, so the first, the second, the 50th, or whatever, is going to be our estimate for the lower quartile. It doesn't tell us what the lower quartile is, but it does tell us which value we can consider it to be. We are then going to work out which interval or bar the lower quartile is in, and then finally we're going to use the rearranged form of that equation that we mentioned earlier, i.e. to work out class width, to work out what the lower quartile is. As always in maths, it sounds like a bit difficult, but once we actually use it, it becomes a lot simpler. So step 1, let's work out the individual frequencies and then add them up to find the total. So you may have been shown this in a table. So you may have been shown something along these lines. So you may have been shown to just change this. So you may have been shown, make a little table for yourself. So 80 to 90, work out, between 80 and 90 what the frequency density is. Frequency density between 80 and 90 is 2.6. The class width is obviously going to be 80 to 90, that's 10. To work out the frequency, you multiply, so you have 26. And so on. So you might have seen something like that. I'll just make a little change here. So class width 80 to 90, and so on. So you might have seen something like that. Bit neater, 80 to 90. So then 90 to 100. Class width is 10. Frequency density is 3.4. So the frequency is 34. I'm just multiplying the two. 100 to 120. The class width is 20. 120 take away 100. The frequency density is 5. Multiplying the two gives me a frequency of 100. And then the next one is 120 to 140. So the class width is 20. And looking at my histogram, I can see the frequency density is 3. 20 times 30 is 60. Lastly, 140 to 170. Frequency density seems to be, so 1.4. And the class width, apologies, is 30. So I simply do 30 times 1.4. Now 30 times 1.4 is the same as 3 times 14, which is 42. So we have 42. And lastly, we know that in the last bar there's going to be 18, but for the sake of completeness we'll work it out. So 170 to 200, class width is 30, frequency density is 0.6, and 30 times 0.6 is going to be 18. So we got 18. Now let's work out the total. So we have 100, 60, 42, 34, 26, and 18. So working these out, 10, 16, 20, 10, 13, 15, 16, 17, 18. 1 plus 1 is 2. So I can say the total is 280. Now in the GCSE that will be something like 2 marks doing all that. So, you know, fair few marks for not a lot of work really. Just doing some timesing and adding. So we can say there were 280 pupils. So essentially, the histogram you can consider, in a way, it's continuous data, but you can think of it as 280 pupils in a line. So you can imagine, you know, at this end you've got pupils, you know, with a score of 80, holding up a sign 80, going up to pupils at the end, holding up a sign of 200. Holding up a sign of 200. So you can think of them as being in order like that. Essentially, we want to find out where the 70th pupil is. Now, we don't know where that pupil is, because it's not the pupil holding up a sign with 70, because if you look at the histogram, none of them are. That's not what I'm after. What I'm after is the 70th pupil in this sort of list or this line of pupils. So, to do that, and the reason I'm saying the 70th, in fact, is because there's 280 values, and to work out where the lower quartile is, we divide that by 4. So 280 total divided by 4 is 70. The 70th is the lower quartile. The 70th person is the lower quartile. We need to find out where the 70th person is. So we know from the little table that we did that the frequencies go 26. So there's 26 people you can consider in this interval. 26 pupils with a score between 80 and 90. Excuse me, 34 between 90 and 100. And I believe it was 100 between 100 and 120. So we can sort of use a cumulative frequency to work out the numbers of pupils. There's 26 plus 34, so between 80 and 100 is 60. Now we want the 70th person, so we know they're not going to be in here in these first 2 bars because there's only 60 people. Now between 80 and 120, adding up 26 plus 34, 60 plus 100, 160. There's 160 pupils from 80 to 120. So, and there's only 60 between 80 and 100. So I can say that the 70th must be somewhere in this 3rd bar, in this interval. So I'm actually going to state that. I'm going to say the lower quartile, so the lower quartile pupil, the 70th pupil, is in the 100 to 120 interval. And by saying that, I get a strategy mark. You'll probably in a GCSE get a mark for that. Okay, so there's 3 marks now for doing part 4. Now, what we need to do is remember that we're after the 70th person, and the first 60 people are in the first 2 bars. So we need to go a further 10 in terms of frequency. Now that sounds really complicated because the graph doesn't show frequency, it shows frequency density. So we need to use a little bit of algebra. So essentially we want to go into the 3rd bar sufficiently that the frequency, so it's not going to be 110, it's going to be into the 3rd bar, pardon my drawing, that's awful, sufficiently that the frequency will be, the extra frequency in this little sliver is going to be 10. So we can actually work out how wide that bar is. by using the formula from the start. And if we can work out how wide this little sliver is, we can see how much further than 100 the lower quartile will be, and that will give us the answer. So we're inside that third interval, so we know the frequency density is 5 because we're inside that interval. So we can say the frequency density equals 5. We know the frequency is going to be 10 because we need to go a further 10 pupils in. Frequency is 10, frequency density is 5. What is the class width? We don't know, but we can use the formula from the start, the formula triangle. So if I cover up class width, I'm left with frequency over frequency density. So I can say frequency over frequency density is going to be 10 over 5, which is 2. So this little sliver is, in terms of score, 2 units wide. So that means the lower quartile is not 100, it is 102. And that will be the final answer. The lower quartile is 102. So have a practice using this question here. So I've adapted another question. Now this one is not going to have particularly nice numbers because it's not designed that way. But let's see if we can complete this question too. So if you want to give it a go yourself, pause the video and then resume it when you want to have the answer. So there are 150 people in the interval 20 to 50. I want to complete the histogram, so I'm going to do so using the formula frequency density is frequency over class width. Now the class width between 20 and 50 is 30. The frequency is 150. Now 150 over 30 is 5, so that means that between 20 and 50 I want to have a bar which is 5 high in terms of frequency density. So that's my completed histogram. I now want to find the lower quartile. Now I've told you there's 550 people working here, but usually you will not be told that total and you will have to work it out. So let's operate under that assumption. Now between 0 and 5, you obviously got a class width of 5. There's a frequency density of 21, 22, 23. So to work out the frequency, so the number of people who have to travel between 0 and 5 miles to work, I would do 23, my frequency density, times 5. Now this is where my arithmetic comes a cropper, but that's going to be 115. Between 5 and 10, I should be doing this in a table, but for the sake of time I will do it this way. Class width is 5, frequency density is 35. 35 times 5, 150, 175. Between 10 and 20, class width is 10, frequency density is 11, so I have 110. And then between 20 and 50, class width is 30, frequency density of 5, I have 150. Now let's do the total to make sure. So we have 115, 175, 110, 150. So 10, 7, 8, 9, 14, 15, 1, 2, 3, 4, 5. So that does work. Okay, so that does add up to the total. So I've worked out the frequencies and found the total. Now, showing all the workings for that and doing it will give us 2 marks. I'm going to divide the total by 4 to find out where the lower quartile is. It's going to be a decimal here, but actually it might, yeah, it will be, and that's fine. So 4, 8, 12, 3 with remainder 3. That's going to go 7. 4 to 3 goes 7, remainder 2. Then 4 to 20 goes 5, 137.5. So I want the 137.5th value. And we can use our cumulative frequency to find it. First 115 are in the first bar, and then the second bar has 175. So that means the 115th must be in the second bar. So I will state that for another mark. I will say the lower quartile is in the interval 5 to 10 miles, and we need to see how far into that bar we need to go. So we know the first bar has 115 values. We want the 137.5th, so I'm going to do 137.5, take away 115. So I'm going to have to do that with columns because I just do. So 5 to 2, 22.5. I need to essentially go 22.5 into that second bar, and that's going to be the frequency. So in this second bar, I know the frequency density. If I look at the second bar, the frequency density is 35. I know the frequency is going to be 22.5. Don't worry, there's not a whole number. This is continuous data, so don't worry. And I know the class. Well, I know that to get class width, I do frequency over frequency density. So that's going to be 22.5 divided by 35, which is going to be 15 by 5. I'm just going to use a calculator for that, if I may. Simply because this is not designed. There's so few of these quartiles questions with histograms that I've had to make this one. I've had to adapt it from somewhere else. Doing that will give me 9/14, which is 0.64 roughly. So again, this would be a calculator question. 0.64 we'll call it. You won't have one with numbers this bad in a non-calculator exam. So we have 0.64 for our class width, and we need to go from 5. So I would say the lower quartile is 5 plus 0.64, which is 5.64.